So from the poll, what I found was that a lot of people struggled with the issue of confounds. So I'm going to spend a minute talking about confounds or confounded variables, more technically speaking, in research experiments and design. So when we start with thinking about an experiment's pretty straightforward. You keep everything constant and you change one thing, and you look for what else has changed as a result. Or you keep everything constant and you allow one thing to change and look for changes someplace else. So the difference between these two is that you may manipulate a variable, or you allow a variable to change. Sometimes you can't manipulate it, but you allow differences in your experiment. In other words, you control all the variables possible in the world that you can. You change your independent variable and you measure your dependent variable. Now, you can't control everything, and thus we call these things extraneous variables, variables that we're not interested in looking at, but we don't control them. We just don't know what they do, but what we think is that their effects, if there are any, are spread out amongst all of our participants or all of our groups, are evenly distributed. The effects of these extraneous variables are evenly distributed across the groups as long as we've randomly selected or randomly assigned treatment conditions. So the randomization routine spreads out equally these issues. As we get to the next chapter when we talk about equivalent groups, that may not be the case, but we'll get there. So they may be influential, but they're not everything, and they're not, you can't control everything. So you got to roll with it. For example, I just put this noisy versus quiet, and that is that sometimes you do an experiment and there's noise around that you can't control, and sometimes there isn't. Imagine doing a research project and they started construction, on the local road, and you can hear the pounding of the jackhammers or something like that. And another day there isn't. You hopefully that will balance out, that'll wash out in the arrangement. But on the issue of confounded variables, these are extraneous variables that co-vary with the independent variable. What that means is, as the independent variable changes, this extraneous variable is changing systematically. It co-varies with. So if the independent variable goes up, the certain features of the extraneous variable go up or go down depending on the relationship. So if you have a confounded variable, you're done. You're toast. You're finished. Finito. There's nothing you can do in a confounded variable circumstance or situation. If the experiment is confounded, you have to drop everything and start again. So let's illustrate this by the exercise 5.2 in your book, which I think is a really good format or heuristic or model for looking at confounded issues. So I gave you this example. A testing company is trying to determine if a new type of driver, that is a golf club, will drive a golf ball greater distances than 3 competing brands. So 20 male golf pros are recruited. Each golfer hits 50 balls with club 1, then 50 more with club 2, then 50 with club 3, 50 with club 4. To add realism, the experiment takes place over the first 4 holes of an actual golf course. The first set of 50 balls is hit from the first tee, the second from the second tee, and so on. The first 4 holes are all 380 to 400 yards in length, and each is a par 4 hole. So what are the confounds in this experiment? Well, hopefully you understand what we're doing, or what the experimenters are trying to do. And that is, let's remember what an experiment is. Hold everything constant, change the independent variable, and look at the dependent variable. So in this case, our independent variable is the club. We have 4 levels. We have club 1, 2, 3, and 4. And our dependent variable is the distance that the golf ball is driven. We'll probably be looking at mean distances after hitting club 1, mean distance after club 2, club 3, and club 4. Okay, so that's the experiment. Now, what sort of extraneous variables are in this scenario? Well, the first thing is, what could affect how far a golf ball is driven? Well, one thing is the expertise of the golfer. If a golf pro was hitting the ball and I was hitting the ball, he would probably outdrive me just because I'm a lousy golf player. Or maybe you've never played. So we didn't recruit. The experimenters didn't recruit just any average Joe. They recruited pro golfers. So one of the extraneous variables in this is whether it's a pro golfer or not. And you might say, well, does a pro golfer have any? Well, probably. It turns out, yes, I think so. I know enough about golf to know that, for example, I can't hit a graphite driver, a driver with a graphite shaft. I can't handle, but that's what all the pros hit, and they have a particular way of doing it. So how far a golf ball is, but in this case, we have all pros. Now, what else could be a factor in how far a golf ball goes? Well, what about fatigue? It's another possible extraneous variable. I mean, if I got you up at 6 in the morning and I had you hit 50 golf balls, and then right before bed had you hit 50 golf balls, you might be tired at the end of the day so that's a possibility. And in fact, Club 1, if you remember reading the details of this little experiment, they're fresh when they hit the first club. They get warmed up a bit, then they're tiring, and then they're tired when they get to golf club 4. So that's an extraneous variable that may be a little weird. Another extraneous variable is the hole. Would this make any difference? Well, Club 1 was hit on hole 1. Club 2 was hit on hole 2. Club 3 was hit on hole 3. Club 4 was hit on hole 4. Now, they said they're all the same length, and they're all par 4, so maybe those are equal. But let's look at this a little bit further. I put this now in table form. Again, remember, an experiment is holding everything's constant, changing the independent variable, and looking for changes at the dependent variable. So if we look at this extraneous variable, have we held it constant? And the answer is yes, we have held it constant. Therefore, there is no confound in between the IV, the club, and the expertise of the golfers. Now, let's look at this next one, this fatigue level. Have we held it constant? No, we haven't. We haven't. What people are never fresh, the golf pros are never fresh when they hit club 3 or club 4 or club 2. They're always at various different stages of they only hit club 1 when they're fresh. So this does co-vary with the independent variable. It moves with the independent variable, and therefore it is definitely a confound. Okay, let's look at this last one, the hole. Is it constant? Does it co-vary with the independent variable? Absolutely. It is not constant. You never hit club 1 on hole 4. You never hit club 2 on hole 3, in all sorts of combinations there. It does co-vary with the IV. This is also a confound. And you might say, well, what's the difference? They're the same difficulty because they're both par 4s. They're both, 300 to 400, 380 to 400 yards in length. What could be the difference? Well, what if we looked at the elevation of the holes? Maybe hole 1 starts on a hill and goes down, whereas hole 2 starts in sort of a valley and goes up. In this case, you would expect hole 1, balls hit off the tee in hole 1 to travel a lot farther than you would in hole 2. Therefore, this is a significant confound. The hole type and the club co-vary, and they're confounded. In this experiment, you can't tell anything. They may hit farther in club 1 with club 1 merely because there's a hill there and the ball travels farther on the hill. Hopefully that helps you a little bit with confounds. I would use that heuristic or that model if you're struggling with what is a confound and what isn't. Talk to you later.